Welcome to Study with Sri. In this video, we are going to start an extremely important topic, exponents and logarithms. This topic is essential for GCSE students, A-level students, and it is also heavily tested in competitive exams like IMAT, UCAT, UCAT, SAT, MCAT, and everything. Before we move into difficult questions in the logarithms or else the exam level problems, we must build our fundamentals very clearly, and that starts with the laws of exponents. So whenever we study these laws and stuff, you have to be very clear with the fundamentals, and you should not just by heart the laws as it is. Rather, you should understand how these laws are applied, and you should understand that you should clearly able to understand that clearly. Then it would be easy for you to approach, and if you are good with the fundamentals, constructing and approaching the complex questions going to be very easy. So let me start this exponents and logarithms with a small story, because we should know where we use these exponents and logarithms in our day-to-day life. So let me start with a small idea. Just say you're saving money in the bank, and every year your money doubles. The growth doesn't increase in a straight line. It increases faster and faster. Am I right? Because it's not going to increase linearly. It's going to increase faster and faster. This kind of growth appears everywhere. The population growth, radioactive decay, compound interest in the bank, and some physical formulas, and even the algorithms in the computer science. So everything is following this trend. So mathematically, all of this is controlled by exponents. And if you don't understand exponents properly, logarithm will feel very difficult later. So understanding exponents fundamentally very important to excel in logarithms as well. So today we slow down and get the foundation right. What is an exponent? So let's try to understand. Let's begin with meaning of an exponent. So just say an. Here a is called the base and n is called the exponent or power. So it is simply means multiply a by itself n times. For example, if I say a to the 3, how can we read this? We can read this a to the power n, or else a raised to the power n, or else a to the n simply. See this example, a to the 3. It can be written a times a times a. So this simple idea will help us understand every rule that follows. So let's see the first law. The first law is a to the m, a to the n can be written as a to the m plus n. So this is the first law. Let's try to understand the credibility of this law. For example, let me take a to the 2, a to the 3. Let's expand it. A to the 2 means a times a. A to the 3 means a times a times a. So how many a's we have in total? We have 1, 2, 3, 4, 5. So if you count it, so instead of writing everything, we just write a to the 5. It's simply we are just adding the powers. So the first law explains when the bases are identical, you must understand when the bases are identical only we can count them. So simply this rule only works when the base is the same. When the identical base is there, we can simply add the power. We can simply add the exponents. So this is the first law of exponents. Now let's think about the second one. So the second law, a to the m divided by a to the n, is known as a to the m subtraction n. So for an example, a to the 5 divided by a to the 2. How do we write it? A times a times a times a times a divided by a times a. You cut this a and count the remaining, that is a to the 3. So division means simply you see when the base are identical, you can simply subtract the power rather than writing everything. So the law says the same. So when the base is identical, we can subtract the powers. So division means we subtract the powers. See the example, x to the 7 divided by x to the 4. You can write x to the 7 minus 4, 3. It's only possible when the base are identical. Here the base are identical, so you can simply write it. So this is the second law. Now let's talk about the third law. So the third law, the power of a power. For example, a to the m to the n. This one can be written a to the m times n. For example, let's say x to the 2 times 3. Just imagine this x to the 2 to the 3 means what? X to the 2, it is multiplied by itself for 3 times. So x to the 2, x to the 2, x to the 2. Now simply you can understand here, you can see this is the first law. All the bases are identical. You can simply add the powers, which is 6. So the powers multiply. You can see 2 times 3, which is 6. So I can write, so the powers multiply x 2 times 3, which is x to the 6. So please don't memorize these kind of rules blindly. Every difficult question in exams becomes easy if your fundamentals are very strong. Exponents are not exponents. Whatever the exponents that we are studying here, these are not tricks. They are logic. You should understand that logic. Is that clear? So now it's your turn. Just tell me 2 to the 4, 2 to the 3. How do we solve it? First you have to check the bases are identical. They are multiplying. So you have to add the powers. 4 plus 3, which is 2 to the 7. And see another example. X to the 5 to the 2 divided by x to the 3. In this case, try to understand x to the 5 times 2, the powers multiply 10 divided x to the 3. This is division, the bases are identical, so you can subtract the powers 10 minus 3, which is x to the 7. Okay, so this is a very interesting idea to solve. In this way, let's try to understand let's try to see 2 more examples. Let's see another example. For example, 3 to the minus 6 divided by 3 to the 8. First we have to check whether the bases are identical. Yes, it is identical. It is division, so we subtract the power. 3 minus 6 subtract 8, which is 3 to the minus 14. Usually in exponents, we don't write the exponents in negative powers. It's okay to write, but conventionally we don't write that. So we want to write it as a positive power. So we write it as an exponent. We write it as a reciprocal of it, which is 1 over 3 to the power 14. When you write the reciprocal of this negative sign will become positive. Just see another example. If I say x to the power minus 5 means, if you write the reciprocal, which is 1 over x to the power 5. So the numerator, here the sign, numerator becomes denominator, so the sign changes. So I'm going to give 2 more questions. So you're going to try these questions and say your answer in the comment section. And in the next session, I'm going to explain them. So you're going to try 1 over 8 to the power 2 divided by 1 over 4 to the power 4. And 9 raised to the power 7 multiplied by 1 over 3 to the 4. So in the next video, we will first discuss your doubt from the comments, and then we will move forward into more advanced exponent problems and gradually connect this to the topic to the logarithms. So we can gradually connect this idea to the logarithms if we are very clear with the exponents. So if you found this helpful, like the video, subscribe to Study with Sri and share it with your friends. So see you in the next session. Bye.